Okay, I'm going to talk about one of the most fundamental inequalities of all. X is any number. I'm going to make the very straightforward observation that x squared is greater than or equal to 0 for all x. Equality if and only if x equals 0. The proof of that is rather messy. X can either be greater than or equal to 0 or less than 0. If it's greater than or equal to 0, x squared is greater than or equal to 0, and if x is less than 0, then x squared equals minus x times minus x equals x squared, which is greater than or equal to 0, actually strictly greater than 0. Let's just get rid of that. Strictly greater than 0. The proof is rather messy. You just got to split the real line into positive and negative bits, each bit of which gives you the same conclusion. You can see it a lot more easily by plotting it like that. Not very well plotted, but there it is. Y equals x squared, and there's x, and there's your point of equality. I'll sort of put a big blob there to hide my poor drawing. You'll notice that if you compare this picture to y equals mod x, you'll see it's a lot. This one's a lot of a much more fine statement. I guess if you did calculus, you'd say that the derivative was 0 there, whereas this is a sort of spiky bottom here. Whereas this is a very much more fine inequality. X squared greater than or equal to 0. It's one of two massively useful inequalities. The other one being e to the power x is, in this case, strictly positive for all x. Yeah, it's a very pedestrian observation, but very useful. Let me show you how you can use this. Let's try to find the minimal value of x squared plus, let's say, alpha x plus beta. Well, I guess if you knew calculus, you'd just differentiate it and set it equal to 0, but we can do better. We can do better. I can give a much nicer proof. Let's say f of x equals x squared plus alpha x plus beta. Alpha and beta are just constants here. Equals x squared plus alpha x plus alpha squared over 4 minus alpha squared over 4 plus beta. What have I done here? I've added and subtracted alpha squared over 4, and of course you'll recognise what I'm doing. What I'm doing here is completing the square. X squared, no it isn't, let's just do that again. It's x plus alpha over 2 squared plus the other bit here, which is this bit here, beta minus alpha squared over 4. So let's just have a look at this. We've got two components here. We've got this component and this one here. This one is always strictly positive, and this one's a constant. So we know that f of x, which was this quadratic here, equals beta minus alpha squared over 4 plus something positive, or something non-negative, I guess. Something non-negative. Therefore, f of x is greater than or equal to beta minus alpha squared over 4 for any value of x, which is quite an interesting and useful observation. We'll use this kind of thinking over and over and over again, as we'll see in future screencasts. But I'm going to stop there with the take-home message that x squared is always non-negative, and I'm going to stop there.